Hello friends, welcome to engineering tutorial. So we are going to discuss I think the fourth question related to the application of Thevenin theorems to electrical circuits. So this is the circuit that we have and has been asked to find the Thevenin equivalent circuit across the point 1 and 2, VTH and RTH. We have to find out across these 2 points. So first we'll find VTH and then RTH. Okay, so in order to find VTH, I think here it is good to apply mesh analysis. So first let us assign the respective branch currents and polarities. Okay, let us say a current I flows through there from 30 volt. Here 5 ampere is coming, so they to get added up here to form I plus 5 flowing through 10 ohm. Here 5 ampere is coming, here also it is going 5 ampere from here. 5 ampere is going. So here it will be only I. Okay, and all the branch currents have been assigned. Let's assign the polarities. So it is plus minus and plus minus. Okay, and this is also plus minus. Okay, here now we will apply mesh analysis to find out the value of I. Only then we can go for VTH calculation. So starting here, applying second sign dominating KVL, the equation is 30 minus 10I minus 10 into I plus 5, okay, minus 5I is equal to 0. Okay, plus minus I have assigned because power is always absorbed in resistor. So power absorbed means plus minus. I have already discussed that in the previous videos. So solving it, 30 minus 10I, opening the bracket, minus 10I minus 50 minus 5I is equal to 0. That implies 30 minus 10, 25I minus 50 is equal to 0. That implies minus 20 minus 25I is equal to 0. 30 minus 50 is minus 20. That implies I is equal to minus 20 by 25 ampere, or cancelling it by 5, minus 4 by 5 ampere. Okay, I is negative. So what this negative essentially means, that the current direction that we assumed, okay, starting from 30 volt, the direction which we assumed, the direction of I, okay, here the direction of I that we assumed here, it is the opposite of that. It is actually in this direction and has a magnitude of 4 by 5 ampere. In this direction, if we assumed, it would be minus 4 by 5. Minus essentially means that the direction of current which we assumed, it is the opposite of that. Don't be confused that our answer is wrong, the answer is coming in negative. Most of the time students think that when the answer is coming negative, it means it is wrong. No, it is not that. Here we assumed that we took an assumption, let's say that I is flowing in this direction. Okay, everything is correct here. just is that our assumption is not wrong, but it is the opposite of that. So minus sign essentially means that. So it is actually in this direction, downwards. Okay, downwards. Okay, that is the direction, actual direction of I. So no need to change anything about the circuit. We got the result as minus 4 by 5. Let us keep that. Now we have to find VTH. So let us assign VTH here. This is the Thevenin voltage across these two terminals. Let us call it as VTH. Let us apply KVL in this mesh. So here again, using the second sign dominating method, 5I minus 5, here 5 ampere is flowing through 16 ohm. So it is 5 minus 5 into 16 minus VTH is equal to 0. That implies 5 I's we got minus 4 by 5 minus 80 minus VTH is equal to 0. Cancel. So minus 84 minus VTH is equal to 0, or VTH is equal to minus 84 volt. So here the voltage, Thevenin voltage, we are getting minus 84 volt. So it means it is not, it does not mean that the answer is wrong. It means the direction, the polarity of the VTH that we assumed, it is the opposite of that. Here we assumed plus minus, the top terminal is plus, the bottom terminal is minus. So it is the opposite. So it is minus plus. If we would have assumed this, then our answer would have been correct. Our answer would have been correct. Okay. So it is the same thing. Let us keep that plus minus. That is the convention, the proper convention. So plus minus VTH, that is equal to this. Okay. So this is the answer. We have got VTH. Now we have to determine RTH. Okay, so VTH we have got. Let us write it down here. VTH is minus 84 volt. Let us find out RTH. So we have found out VTH minus 84 volt. Now let us find out RTH across these two terminals. So before doing that, first we have to deactivate the independent sources. Here we have two independent sources, one independent voltage source, one independent current source. So voltage sources should be short circuited. This is only for RTH calculation, okay? They are short circuited. Current sources are open circuited. So now RTH. So here we can see that these two 10 ohm are in series. Their resultant is in parallel with 5, which is in series with 16 ohm. So 10 parallel 10 is in series. Sorry, 10 and 10, these two are in series. The resultant is in parallel with 5. The total resultant is in series with 16. Let us do that. So RTH is 10 plus 10 parallel 5 plus 16. Okay, this is the final result. So it is 20 parallel 5, which is 20 into 5 by 25 plus 16. Okay, so it is 100 by 25, which is 4, which is 4 plus 16, which is 20 ohm. Okay, so RTH is 20 ohm. So we have found out both VTH as minus 84 volt, RTH as 20 ohm. Okay, so for RTH we deactivated the two independent sources. Voltage source 30 volt was short circuited, 5 ampere current source was open circuited. Then we found out RTH across these two terminals. Okay, so both VTH and RTH, which was asked in this question, we have calculated. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.